Hi class, Mr. Gray here again, doing another video on Pythagorean Theorem, or what I call PT, all right? That's going to be our unit 4 of our math concept for year 3. So basically what this Pythagorean Theorem ends up adding together is basically two different concepts, okay? You getting some geometry work and learning about shapes of the right triangle, and getting prepared for that for 10th grade, and also some exponents and some inverse work that we've already started before. So it's kind of like a building off those, but then it's adding in that geometry portion to that as well. Okay. So again, I could do this in a real crazy way of trying to get you to understand this and kind of discover Pythagorean theorem, but unfortunately we're using this virtually, so we don't really have a lot of time to get in depth like we would in class. So I'm basically just going to give you the information that you need to solve these problems and kind of move on from there. Okay, so again, PT, Pythagorean theorem. There are some requirements to Pythagorean theorem that you need to know first. Okay, that's the two most important things. Okay, number one is that Pythagorean theorem, you need to have a right triangle, okay, to do it. And now there could be three different types of right triangles. It can be obtuse, it can be acute, and it can be the sauce-meaty right triangle. But the thing is, Pythagorean theorem only works with right triangles. So basically, you have to have certain requirements to make it work. Now, there is some that, again, you're going to say, well, what about the irregular triangle? There is some other ways to do it of law of sines and law of cosines that you can use to work irregular triangles as well. But that's like 10th grade stuff that you'll probably learn about later on. Okay. All right. So first thing is first is like basically the identification. Okay. So we got a squared plus b squared equals c squared. Okay. Now, and everybody's like, what the heck? Which one is a? Which one's b? And which one's c? Okay. So the idea is this is a right triangle. How do I know? Because of this little figure right here, this little corner box here. This determines that it's a right triangle. Okay. Okay. And again, it's not by the look, it's by the actual what's on the side here. So if we didn't have this, it wouldn't be a right triangle. Okay. Basically by the decoration. All right. Now, from this right triangle, okay, now the sides that touch the right triangle, the little symbol for the right triangle, are called the legs. Okay, so those are basically the legs of the side. Okay, now they would be the values. They would be A, and this would be B. Okay, now the great thing about it doesn't matter which one is A or B. They both can be different. Okay, but they both have the same idea of A and B. Okay. Now the last portion is what is the C value? Okay, the C value is going to be the hypotenuse. So that's going to be C. Okay, so basically hypotenuse is always the opposite the right angle. So it's always the side, I forgot to put side, opposite the right angle. Okay, so again, here's the right angle. Opposite of the side is always going to be the hypotenuse of the longest side. Okay, I still don't know why they call it hypotenuse. I really haven't looked that up, but like I said, that's where you go. So again, you could use this equation of Pythagorean theorem to determine every side of the right triangle if you wanted to, okay, based on the information. So we're going to use this information here, like I said, and we're going to use this equation to determine different side lengths so we can kind of get an understanding of how to use Pythagorean theorem, okay? So let's go down and try one here. All right, so we have a value of, there you go. Gotcha. Okay, so we have a right triangle here. We have a right triangle here. So first thing is we want to do is identify. Okay, so we want to identify the sides. Okay, leg or hypotenuse, LLH. Okay, so again, we know that this is the right triangle. Opposite of that is the hypotenuse. So this is the H or the C. Okay, this side right here is the leg. So this is the A. And this side right here is the B. So again, like I said, you can switch either one. It doesn't matter. Okay. So what we have to find for is the B here. Okay. We have to find for the B. All right. So that one is going to be, now let's think about it. How are we going to do this? All right. So let's take out the equation. A squared plus B squared equals C squared. Okay. So we know we have the A. So that's going to be, we're going to substitute a, we're going to substitute a 6 squared. We don't have the b squared. And then we're going to have 14 for c, so that's going to be 14 squared. Okay, just like that. All right, so now let's go ahead and go about solving this. We talk about how this goes. Okay, so looking at the information here, what do we have? We have 6 squared. So 6 squared, if you remember that, is 6 times 6, so that's 36. Okay, and then we have plus b squared. Okay, equals, now 14 times 14 equals 196. Okay, so now looking at the equation, we have 36 plus b squared equals 96. So from here, what can we do? All right, so to get b by itself, so we're going to find the value of b, we got to minus 36 from both sides of the equation. So now we end up with, I'm going to move this up here because I have another problem down here. B squared equals 160. Okay. Now the question is, it's like, okay, we have b squared here. We don't have 2b equals 160. Now we have b squared. So the idea is, okay, what's the inverse of squaring a number? Okay, what's the inverse of that? Okay. What's the inverse of squaring a number? Well, think about it, okay? Square root, right? Because square and its root is the smallest you could possibly be. So the inverse of this would basically be square root. This is where we talked about before of the inverse operations, how square and square root were inverses of each other. So therefore, to get the square off, I'd have to square root both sides of the equation. So this eliminates, end up with b. Now I need to know what the square root of 160 is, okay? Then we got to remember the technique. Remember perfect squares? We made this tree. We found out what the perfect squares were. Okay, so we're going to do the same thing. So let's go 16 and 10. Okay, that's probably the easiest one. Okay, because again, we got 16 here times 10. That gives us 160. And we know that 16 is a perfect square, right? So we square root 16, what are we going to get? 4. Okay, and then with square root 10, we can't split it apart to make it any smaller. So it would be square root 4 square root 10. Okay, so the missing side would be, again, this is going to be tricky. Okay, is 4 square root 10. All right. So again, like I said, we're starting to put together different foundational things together with our math, so we can start working on it. That's why we worked on a lot of foundational stuff in the beginning. Okay, because we wanted to be able to be good at this stuff as we go along, and we had some familiarity before we started. Okay, so that's how you would do that kind of question. Okay, so let's try another one. All right. So we have this one here. We have, okay, first, like I said, first thing we have to do is identify legs and the hypotenuse. Okay, so now we have the right triangle here. Opposite would be the right hypotenuse, so this would be the height equals C. Okay, and then remember we said anything that's touching the right triangle is the leg. Okay, so this one is a leg, this one is a leg. And remember we said they're both interchangeable, so this is A, this is B. It doesn't really matter. Okay, so now let's take the equation, let's work with it here. So we have A squared plus B squared equals C squared. Okay, so again, A squared would be 4 squared plus 11 squared equals C squared. Okay, 4 times 4 is 16. I think 11 times 11 is 121 equals C squared. Okay, now we do the math here. That's going to give us 137 C squared. Okay, now I'm actually going to move this up here over here. So 3 squared equals 137. Now, what did we say before? What's the inverse? Inverse of squares. Inverse of squares is basically square root. So we square root both sides by 137. So this cancels off. So this is C, and this is square root 137. Now, I'm not going to break it down any farther because, again, I probably could, but I think it'd be easier just if I found a perfect square of that. Nah, it's easier just to keep it the way it is, okay? Actually, let me see. Change that around real quick and see what it looks like. No, 11.17. Okay, so sometimes this one's probably not an easy perfect square to break down, so I just leave it the way it is and call it a day. Okay, so this would be the square root of 137, which is which would be about 11.7 if you actually did the math out. It's approximately 11.7 if you square root of 137. So again, I would accept the answer of square root of 137, or I'd say 11.7 works for me as well. Okay. So remember, you don't have to square root and move this down if it's not easily squareable. So just want you to get familiar with that. All right. So again, that's how you would do that type of problem. Okay. All right. Let's try another one. Now let's get a little harder here. Again, we're looking at different angles here. All right. So now we have a right triangle here. So we need to find, we already know what we're missing. We're missing the hypotenuse, which is C. So we have B is square root 40, A is square root 10. Okay, so let's do the equation. So first thing we have A. So whoops. So let's put that on the side. So square root 10 squared plus square root 40 squared equals C squared. Okay, so let's think about it here. So we have square root 10 times squared. Okay, so you think about it. If you have square root times if you distribute your square root and square it, okay, that means they would eliminate each other. So they would cancel. This would cancel and this would cancel, and you end up with just a whole number 10. Okay, same thing here. So these are inverses of each other. So if you multiply this by square root 10 by square, the square root, the sign is going to fall off, and it's just going to be 40. Okay, so that's what happens when you, again, inverse the other way too. They both fall off. So you get the square root, and you have a square on the outside. That means that the square root will be eliminated, and this becomes a whole number. Okay, you add these two together. That's going to give us 50 C squared. Okay, and then what do we do at this point? Remember, like we said, we square root both sides of the equation. Choose this up here. Okay, so it becomes C. Now from here, remember 25 and square root 2. Okay, so this looks down to 5 square root 2. And that's what C is. C is going to be 5 square root 2. All right. Tough questions, guys. I know these are tough, but like I said, we'll continue to practice these for the next day, this day, and also Thursday. And I think that we should be good going forward and working on these. Okay. So again, these are 3 problems that you'll have to do today in class, in your weekly exit ticket work. So again, please get this done. And like I said, we'll see you all later. Bye now.